Okay, good afternoon, students. Today we are going to discuss some basic problems. These problems already you have studied in your schools, 12th standard, 11th standards. Okay, you see here the OX. OX is the horizontal line, horizontal path. The body is moving from O to X direction. So the starting point O, the particle is moved up to P point. Okay, so what is O to P? The distance S. S equal to distance traveled by the body. How much distance traveled by the body? T equal to time taken by the body in seconds. Okay, the body traveled to O to P distance. So what is the distance? Yes, distance traveled by the body. T, time taken by the body in seconds. V equal to velocity of the body. Small a rate change of displacement with respect time. We know definition of velocity ds by dt. That is rate of change of displacement divided by time taken. Therefore, V equal to ds divided by dt. Then acceleration. What is acceleration? Rate of change of velocity with respect to time. Small a equal to dv divided by dt. Small a equal to dv by dt. What is we know v equal to ds by dt. Therefore, the other definition, the a equal to d square s divided by dt square. Understand? D squared s divided by dt squared. See here, small a equal to d squared s divided by dt squared or dv by dt. So you now know what s equal to distance, t equal to time, v equal to velocity, a equal to acceleration. V equal to differentiate with respect to time. Differentiate the distance with respect to time. What is acceleration? Differentiate velocity with respect to time. Understand? Now simple problem. Just imagine this some boat is moving. Okay, the equation s equal to 3t cube divided by plus 2t square plus 6t plus 4. Okay, and s equal to 6 plus 5t square plus 6t cube, and s equal to 2t cube plus 4t minus 15. Sometimes the given equation motion in terms of displacement s and the time t. Examples. These are the examples for s in terms of displacement time. Okay. Now differentiating both sides. 3 equation, no. But this for just understanding. You differentiate first equation. ds by dt. ds by dt equal to 9t squared divided by 9t squared, yes. 9, 3 into 3, 9t squared. Differentiate. It is 9t squared. 2t squared differentiate 4t. Okay. What is 60? 6. Constant? Differentiate constant 0, no. They neglected. Now differentiate this equation, ds by dt, second equation. So 6 becomes 0. 5t square, that is 2 into 5t, that is 10t. Here, 10t. 60 cube, 3 into 6, t square. Differentiate. 18t square. See here, 18t square. Understand? Then differentiate the third equation. ds by dt. ds by dt equal to differentiate. Class rep, can you differentiate this equation, last equation? ds by dt. Class rep? Vignesh, can you differentiate now this third equation? Therefore, ds by dt equal to 6d squared, 6t squared plus 4. See here. Okay. Class rep, are you there? Vignesh? Mohammed? Okay, differentiate. This is the first differentiation. No, that is velocity. We know velocity equal to what? Students, velocity equal to ds by dt. Suppose the equation given, the first differentiation becomes velocity. Now second differentiation, that is d square by dt square or du by dt. Now we want acceleration. Okay, so we can differentiate this again. Okay, what is 9t square? Difference is 18t. Okay, then 40, 4. 6 difference is no, the 0, it becomes 0. You know differentiation, I think so. Okay, now you see the second equation. Differentiate ds again, ds divided by dt again, differentiate. Therefore 10t becomes 10. 18t square, 36t. Understand? Then ds by dt, third equation. This is for example. Understand? Are you hearing me, students? Are you hearing me? Any questions, students?
No, sir.
Okay. Very simple steps. No, this is differentiation. No. Now the simple problem. Now read this question. Class representative, read this question.
Okay, sir. A particle starting from rest moves in a straight line whose equation of motion is given by S is equal to velocity acceleration.
So a particle starting from rest moves in a straight line whose equation of motion is given by s equal to t cube minus 2t squared plus 3. Find the velocity and the acceleration of the particle after 5 seconds. After 5 seconds. So as we know, s taken out, s equal to the equation. They ask the velocity, no. What is the first v equal to? We know v equal to ds by dt. Students, we know velocity equal to, see here, ds by dt. So differentiate. First differentiation. What is the t cube differentiation? 3t squared minus, what is the 2t squared differentiation with respect to 4t? 3 difference constant, no, 0. So no need, right? So v equal to ds by dt equal to 3t square minus 4t. What is the t value given already the question? T equal to 5 seconds. Therefore, velocity at t equal to 5 seconds. Therefore, v equal to 3 into 5 whole square minus 4 into 5. Therefore, 55 meter per second. Students, velocity unit meter per second. Understand? Now they asking acceleration. Yes. What is acceleration? Again differentiate. The velocity, no, we already do a differentiate, no, ds by dt velocity. Again differentiate. What is 3t square differentiation? 2 into 3, 6. Okay. So therefore 60 minus 40. 40 differentiation. Okay. Acceleration. They're asking at t equal to 5 seconds, what is acceleration? Now applying this equation, therefore a equal to 6 into 5 minus 4. Therefore 6 into 5 how much? 6 into 5 30. 30 minus 4 26 meter per second squared. Very simple question, no? They given the equation yes, that is distance or displacement. S equal to t cube minus 2t squared plus 3. They are asking what is velocity and acceleration after 5 seconds. So what you have to do? We know velocity equal to v equal to ds by dt. So I am doing differentiation. Therefore, t cube differentiation 3t squared minus 2t squared differentiation 4t. 3 constant, no, so difference becomes 0. So I neglected. Therefore, v equal to 3t square minus 4t. T value given 5 seconds. Now apply here. Therefore, v equal to 3 into 5 square minus 4 into 5. So 5 squared how much? 25, no? 3 into 25 how much? 75. 70 minus 20, 55. Understand? Now acceleration. Again differentiate this equation. D squared is divided by dt squared. So 3t squared, what is the differentiation? 60. Minus, what is the 4t differentiation? 4. Now, what is a t? 5 seconds are given the question, no? See here, 5 seconds, students. 5 seconds given. Therefore, 6 into 5 minus 4. Students understand? Any question? Any doubt? Class rep or Viknesh? Ajaj?
No, sir.
Okay. Now, we are moving second question. Class rep, can you read the question now?
Yes, sir. A car moves along a straight line whose equation of motion is given by S is equal to 12t plus 3t square minus 2t cube, where S is in meters and t is in seconds. Calculate. First one is velocity and acceleration at start, and second is acceleration when the velocity is 0.
Gee, here two questions asked. So you go one by one. First read the question, then see the first game. Okay, there are two questions asked, on the first question, velocity and acceleration at start. Then second question, acceleration when the velocity is 0. They ask us two questions. See, whenever they ask in this type of two questions, no, you go by first aim, then go to second aim. Okay. Now see the question. A car moves along a straight line whose equation of motion is given by S equal to 12t plus 3t square minus 2t cube, where S is in meters and t in seconds. So S is given. S is distance given, no? So we know velocity. What is the velocity? ds by dt. Students, first differentiation, ds by dt. What is acceleration? dv by dt. Second differentiation, velocity differentiation, dv by dt, or d squared s divided by dt squared. So we go for first aim. Understand? We go the first aim. Students, here in this question, actually two question asking when the velocity is 0. So they did not given time, no? The previous question they given time. After 5 seconds, see, students, after 5 seconds, what is the velocity acceleration we calculated? See, in this question, they did not given any second, any t. What is a t is a, what is a t? When t equal to some 5 seconds or 10 seconds, they did not mention. What is the condition given? What is the condition? When velocity 0, students, when velocity 0, you have to calculate the acceleration and the velocity acceleration. You will understand. Okay. You see here, condition given at starting time. At start, find the velocity, acceleration at start. This is the first thing at the starting point. In the here, second one, acceleration when the velocity equals 0. So S is given, no? What is velocity? See here, velocity equal to we know ds by dt. Students, ds by dt. So differentiation, ds by dt. 12t differentiation, 12. 3t square differentiation, 60. Minus. Okay. What is a 2t cube differentiation? 60t squared. So velocity equal to 12 plus 60 squared. At starting, students, at starting means what? What is the time? Suppose you are starting, you are traveling from Chennai to that is Thiruvananthapuram or Chennai to Coimbatore. That travel time 12 hours. Just imagine, travel time 12 hours by train. So you are starting from Chennai Central Railway Station. What is the starting time? Class, what is the time, starting time? Suppose you are just imagine total hour 12 hours. You can reach from Chennai to Thiruvananthapuram. Chennai to Thiruvananthapuram. 12 hours. Just imagine 12 hours. What is the starting time? Class rep? Vignesh? So starting means the starting time. Actually, whatever your times at 4 p.m. you can start, or 6 p.m. you can start. But total travel 12 hours. Therefore, starting time t equal to 0. When you reaching Thiruvananthapuram, you see the total time. Suppose you are starting 6 p.m. When reaching total 12 hours, you can count in the hours only. So starting time, as per norms, 0. Understand? Ending time, 12 hours you travel. That is the meaning here. So at the start. So at the start, therefore, see here. At the start, you can take automatically t equal to 0 seconds. The question asked at the start. Students, at the start. At the start means what? Time t 0. Students, time t 0. Therefore, at the starting, what is the velocity? So we differentiated. Now with the applying t equal to 0. Y equal to starting by no. That is applying. So therefore, 12 plus 6 into 0 minus 6 into 0 whole square. Therefore, what is the velocity? 12 meter per second. Understand? Why they are taking t equal to 0 time by starting point. Now, the acceleration. What is acceleration? See here, dv by dt. Students, dv by dt. Now differentiate. Already we got it, no? V equal to 12 plus 60 minus 60 square. Now differentiate this equation, dv by dt. Okay. What is a 12 differentiation? 0. That's why they did not write. What is 60 differentiation? 6 minus 60 square. So minus y we can add it here. What is 60 square differentiation? 2 into 6t, 12t. So A equal to 6 minus 12t. The acceleration at the starting point. They're asking velocity at the start. Students, at the start. At the start point. At the t equal to, okay, therefore A equal to 6 minus 12 into 0. 12 into 0, 0. 6. Therefore 6 meter per second square. Okay. Now acceleration. Now come to second aim. Now come to second aim. Students, second aim they asked, what is acceleration when velocity is become 0? Okay. What is acceleration? When? What is acceleration when velocity equals 0? They're asking acceleration when velocity 0. Already we have velocity equation. No, see here, velocity equation. They mention velocity 0. Therefore, you put to 0. See here, they put added 0. See here, they're equal to 0. Velocity equal to 0. Already we have equation of velocity equation. So you put equal to 0. Then we know this equation divided by 6. Therefore, 12 divided by 6. I replacing minus 60 squared. Take out that I multiply to minus here. Therefore, minus 12 minus 60 plus 60 squared. So divided by 6. So therefore, 60 t squared divided by 6 t squared. Minus 60 divided by 6 minus t. Minus 2 divided by 6. So okay. So you know this calculation, no? What is a squared? That is a x squared plus bx plus c. That in equation, no? Already you studied. Ax squared plus bx plus c equal to 0. Therefore, you know what is x? Minus b plus or minus square root of b square minus 4ac divided by 2a. You apply that concept, find the t equal to 2 seconds. So when velocity is 0, what is the time t? Seconds. They ask no acceleration is 0. So they have taken velocity equation here. They have taken velocity equal 0. Velocity equal then equal to 0. They find the t. After t calculating t, you have to apply in the acceleration equations here. Acceleration equation 6 minus 12 into 2 minus 18 meter per second square. Why minus is coming? Anyone tell me? Why minus? Acceleration is minus because velocity 0 no comes to rest. Students, velocity 0 means what? Comes to rest. Okay, that's why minus. Axis minus. Axis minus means what? Retardation. Negative acceleration. Are you understand? All of you understand these questions, these problems? Any questions? Asaj Muhammad, any questions? Anisa Teres, any doubt? Kavi Raja, Nivedya, are you understand this question? So you read the question first twice, then understand what is the given data given, what are data is given, what is our aim. So you go first aim. They asked velocity and acceleration at start. So we have distance equation, yes, in terms of t. So ask velocity at start. What is velocity v? ds by dt. So we differentiated. So we got some equation. Then at the starting, at the starting means what time? Time t equal to 0. So we applied. So we got velocity. Now again, they asked what is acceleration at the starting point. dt. Understand? Already we have velocity equation, no? So again you differentiate second time. So we got some equation. Acceleration, small a equal to some equation. At the starting, what is the time t? 0. So we applied and we got acceleration. That is the first aim over. What is second aim? What is acceleration when velocity is equal to 0? Students, what is acceleration? Velocity equal to 0. So already we have velocity equation. So they mentioned velocity 0, no? That velocity equation equal to 0. So we simplified. Then we got final t equal to 2 seconds. Now acceleration. You take they ask acceleration, no? When velocity equal to 0. So time t equal to, we got it. So acceleration already we have equation. We apply time t equal to 2 seconds. Then we got acceleration. Any question? Class representative?
No, sir.
Understand clearly?
Yes, sir.
Okay. Now read this question. Class rep, read this question.
The equation of motion of a particle moving in a straight line is given by S is equal to 18t plus 3t square minus 2t cube, where S is in meters and t in seconds. Find velocity and acceleration at start, then time when the particle reaches its maximum velocity, and third is maximum velocity of the particle.
So again, same again they asking. So in this question, the distance given, displacement. S equal to, you can say displacement or distance. S equal to 18t plus 3t squared minus 2t cube. Okay. They asked what? S is in meters and t in seconds. Find first aim. What is the first aim? Velocity and acceleration at start. Students, velocity and acceleration at start. At starting means what? Time t equal to 0. That is your, this concept must comes to your mind. At the starting means time t equal to 0. So what is the velocity? We know velocity equal to ds by dt. What is a ds by dt? So already they given equation. So in the first differentiation, 18t differentiation what? 18. 3t squared differentiation what? 2 into 6, 6t minus, what is a 2t cube differentiation? 3 into 2, 6, 60 squared. So we got velocity equal to 18 plus 60 minus 60 squared. At the asking, no, at the starting, at the start means what? Time t equal to 0. So I apply t equal to 0 here. 18 plus 6 into 0, 6 into 0 square second. Understand? Now they asking acceleration. Students, acceleration. What is acceleration? dv by dt. dv by dt. Already we have v. So differentiate this one. 18 differentiation 0. What is 60 is differentiation? 6. Figure 6. Okay. Minus 60 squared. What is differentiation? Minus 60 squared. Minus 12 into t. Therefore, we got acceleration a equal to 6 minus 12t. At the starting, no, they're asking acceleration. At the start means what? Time t 0. Therefore, a equal to 6 minus 12 into 0. Therefore, see here, 12 into 0. Therefore, a equal to 6 meter per second square. That is first aim over. Students, first aim over. Very simple question. Now, they asking time. See here, find time when particle reaches its maximum velocity. Students, what is the time when it reaches its maximum velocity? They're asking time. Now see here, time when particle reaches maximum velocity. For maximum velocity, let us differentiate the equation of velocity and equal to 0. So you have to differentiate the equation of velocity and equal to it 0. The differentiation of equation of velocity is given by when is the maximum velocity? When is this is wrong, no? When maximum velocity? When acceleration, then when is maximum velocity you attained? Suppose here, the first year. Just imagine, first gear, you are going some speed. Second gear, you are going some speed. Third gear, so the acceleration, students, maximum acceleration 0, you are attaining maximum velocity. You can't go further, no. So when particle reaches maximum velocity, when you attain maximum acceleration, that is acceleration 0. So you take acceleration 0. Here 6 minus t equal to 0. Therefore 6 minus, that is a, what is time t? T equal to 0.5 seconds. See, equating, not equation, velocity equation, acceleration equation. Why acceleration? I told you, no. When the maximum, we go for only fourth gear. When you go fourth gear, what is the maximum speed? Up to, that is maximum acceleration possible. Understand? If you are changing gear means maximum acceleration. First gear to second gear, first acceleration. First gear to second gear to third gear, second acceleration. Third gear to fourth gear, that is third acceleration. So after reaching maximum acceleration, that is you attain maximum velocity. Understand? Therefore, we have to use maximum, that is acceleration equation 0. So equal to 0, because they ask what is time when particle is maximum velocity. When you attain maximum velocity, when you attain maximum acceleration, therefore I am taking the acceleration equation equal to 0. So we got t equal to 0.5 seconds. Understand? Now understand t equal to 0.5 seconds. Now what is the third equation? Third aim. Maximum velocity of the particle. Students, maximum velocity of the particle. So already we got t, no? For maximum velocity, t got it. You apply this t into velocity equations. Equation here. V equal plus 6 into 0.5 minus 6 into 0.5 whole square. Understand? Therefore, 18 plus 6 into 0.5 minus 6 into 0.5 whole square. Therefore, 19.5 meter per second. Are you understand? See, the first aim you can easily understand. Okay, what is the velocity acceleration at the starting point? So you differentiate this equation, ds by dt, that is velocity, you got it. Then at starting, no, at start means what? T equal to 0. Then you applied here, velocity, you got it. Then they asked acceleration. You got acceleration at starting point. At starting point, what? T equal to 0. Okay, that was different, second differentiation. Velocity we have different second differentiation, that is dv by dt. 18 difference is 0, no? 18 difference 0. What is 60 differentiation? 6 minus 6t square. Differentiation 12 tt. At the starting point. At the starting point means what? T equal to 0. See, we applied. What is actually we got it. Now come to second question. You have some doubt. At what is the time? Find time when particle reaches the maximum velocity. Understand? When you are reaching the maximum velocity, I have just now I told you, no. When your first acceleration, suppose the first gear to second gear, first acceleration, then second gear to third gear, second acceleration. What is acceleration? Change the speed is acceleration, no? Then what is the third acceleration? That is fourth gear, third gear to fourth gear. So when you reaches the maximum acceleration, the maximum speed you attained. Understand? Therefore, the equating maximum, that is acceleration, that is this equation. 6 minus 12t equal to 0. Why I am putting 0? Because when the particle reaches maximum velocity, so equal to 0, therefore 6 minus 12t equal to 0. Therefore, t equal to 0.5 seconds. Understand? Now, we take the 0.5. This is the second aim over. What is the third aim? Find the maximum velocity of the particle. So, we know time for. So, velocity equation, already we have velocity equation here. Velocity equation here. That is 18 plus 60 minus 60. So, apply here. You will get maximum velocity of the particle. Any questions, students? Any doubt? Vignesh, Sindhuja, Anisa Tares. Any questions?
No, sir.
Very simple question, no? Okay. Then you just practice. You have to just practice this one. Practice this problem, then you can check the answers. Okay. Now some integration method. If you want to solve some problems, no? So this integration method. Uh, uh, Read this question. Class of read this question.
The motion of a particle is given by A is equal to t cube minus 3t square plus 5, where A is the acceleration in meter per second square and t is the time in seconds. The velocity of the particle at t is equal to 1
One.
second is 6.25 meter per second and the displacement is 8.8 meters. Calculate the displacement and velocity at t is equal to 2 seconds.
So they given one condition, students. In you see the previous question, very simple question. In what way I am telling simple? They given displacement. They given displacement equation AC equal to 60 square minus 2t square plus something velocity. What we have done? We differentiated. What is velocity? ds by dt. We differentiated. Then we applied the time. But the given the time we applied, or starting means the starting time t equal to 0 applied. Then we calculated acceleration. What is acceleration? dv by dt. We differentiate second time, then we applied the time the given we applied, or in the starting point we applied the starting point t equal to 0 we applied, we got acceleration. Now this question, see the acceleration given. Students, they given acceleration, this equation. A equal to t cube minus 3t squared plus 5. So what is A? Acceleration in meter per second. What is t? Time in seconds. Velocity of the particle. Now they given first, they already condition given. What they can see here? Velocity of the particle at t. So when t equal to 1 second, the velocity is 6.25 meter per second. And the corresponding displacement, travel the vehicle, particle, 8.8 meters, 8.85, 8.8 meters. Understand? So already the condition given. T equal to when t equal to 1 second, the corresponding velocity is 6.25 meter per second, and the corresponding distance traveled at displacement 8.8 meters. Now they are asking calculate the displacement and the velocity at t equal to 2 second. Understand? Already one condition given. Now they ask another aim. Calculate the displacement and the velocity at t equal to 2 seconds. Okay. So they asking S and velocity. See the question. See here. Previously the S is given, we calculate directly. Now the acceleration given. Students, now the acceleration given. A equal to t cube minus 3t square plus 5. What is our aim? Displacement and velocity. So we know acceleration equal to what? dv by dt. Students, dv by dt. We know acceleration equal to dv by dt. So now we are going reverse direction. Now going to reverse direction. Previously we differentiate, no? Now integration. See here. A equal to dv by dt. dv by dt equal to, that is acceleration, no? So A is replaced with the dv by dt. T cube minus 3t square plus 5. I am taken the numerator d into numerator. That is this side, right side. Therefore dv equal to t cube minus 3t square plus 5 into dt. Okay. Now differentiate. Both sides we differentiate. Integration. Sorry, integration. What is a dv integration? V. Students, integration. dv integration V. Now, what is a t cube integration? T power 4 divided by 4. Understood? Minus. What is 3t squared integration? 3t cube divided by 3. What is a 5 integration? 5t. So, you know procedure, no? If suppose you are doing any integration, finally you must add the constant, no? Already studied in the 10th or 8th standard. So, any integration, you have to add a constant, no? So, I added first constant C1. So, we got it, students, we got it. V equal to t power 4 divided by 4 minus 3t cube divided by 3 plus 5t plus C1. How we got it? Because already we know acceleration equal to a t cube minus 3t squared plus 5. Our aim is displacement and velocity. So we are going reverse direction. What reverse direction? We know A equal to what? dv by dt. So I have written here dv by dt equal to t cube minus 3t squared plus 5. So I am cross multiplication. Therefore dv equal to t cube minus 3t plus 5 into dt. I am taking both sides integration. Students, integration. See here, integration. So what is a dv integration? V. What is a t cube integration? T for 4 div 4 minus. What is t cube divided by 3. That is 3t cube divided by 3. What is 5 integration? Pi t. So any integration we have to add no constants we added. So we got B in terms of that is t and constant. See now now the first condition given. Students see the first condition. Already the first condition given. When see here velocity of the particle. Students velocity of the particle at t equal to 1 second 6.25. Understand? And the first condition already given. So applying the first condition. So when t equal to see here, when t equal to 1 second, the corresponding velocity given. So here you differentiation, no? Here difference you apply here. Therefore v equal to 6.25. T equal to 1. See here. 1 power 4 divided by 4. Therefore 1 by 4. Understood? Minus. What is t cube? What is a t? 1. Therefore t cube 1 plus 5t. 5 into 1. 5. Okay. So C1 we don't know, just to keep it C1. So after a simplification, so we got constant. Students, we got C1 equal to 2. Now apply again C1 in equation, this equation. Apply here. Therefore, V equal to t power 4 divided by 4 minus t cube plus 5t plus C1. C1, what is the values? 2. So add, understand? So we form the velocity equation again in terms of t. Now what is our aim? Come to our aim. Students, come to our aim. What is our aim? Calculate, see here, calculate velocity at t equal to 2 seconds. Understand? Now apply t equal to 2 seconds. Now apply t equal to 2 seconds. See here, t equal to 2 seconds. What is velocity? Therefore, 2 power 4 divided by 4 minus 2 cube plus 5 into 2 plus 2. So we got v equal to 8 meter per second. Okay. Now we want to, what is another aim? First aim, that is displacement. Displacement when t equal to second. Again, under students, again understand. Already we differentiated v equal to this. We got this equation. Understand? We got this equation. What is v? ds by dt. Students, ds by dt. So I am replacing this equation. So we replace with ds by dt. T power 4 divided by 4 minus t cube plus 5t plus 2. So cross multiplication. ds equal to t power 4 divided by 4 minus t cube plus 5t plus 2. Now integration, students, integration, no. Again, why we are doing integration? We want yes. Why we want yes? In the question they ask displacement. In this question they ask displacement, no. So that's why integration. What is a ds integration? ds integration, yes. Now t4 divided by 4 into dt integration. So d4 what is a d4 d4 5. Denominator 5. 5 into 4 20. Understand? We already know the integration method. Minus. What is a t cube integration? D power 4 divided by 4 plus what is the 5t integration? 5t square by 2. Okay. What is the 2 integration? 2t. I told you, no, any integration we have to what we have to add, we have to add a constant, no. So already we added one constant C1. That is the previous equation. So second constant I am adding C2. Students, I am adding C2. Now boundary condition. What is the boundary condition? The first condition the given question. When t equal to 1 seconds, what is the distance? 8.8 meter. Okay, now applying the boundary, the given first condition. When t equal to 1 meter, 8 s equal to 8.5 meter. So apply here. S equal to 8.8. Okay, what is it? T for 5? T equal to 1 now. 1451. 1 divided by 20. T for 4. That is 1 power 4 divided by 4. Therefore 1 by 4. So 5t square. T equal to 1. So 5 into t square 5 divided by 2. 2t. 2 into 1. 2. Plus C2. Just to keep it C2. Now apply after simplification. So we got C2 equal to 4.5. Again you have to apply. See, again you have to apply here. Yes. Okay. So we condition given the question applied. We got it C2. Therefore S equal to S becomes T for 5 divided by 20 plus minus T for 4 divided by 4 plus 5t square by 2 plus 2t plus 4.5. Now what is our aim? What is our aim? Calculate the displacement here. Displacement after t equal to 2 seconds. Now come to here. Now apply here. T equal to 2 seconds. Okay, what is yes they asked? Therefore 2 power 5. 2 power 5 here apply 2 power 5. What is 2 power 5? 32. 32 by 20 minus 2 power 4. What is 2 power 4? 16 divided by 4 plus 5 tt squared. 2 power 4, 2 power 2, how much? 4. 5 into 4, how much? 20. So 20 divided by 2. 2 into t, 2 into 2, 4, 4.5. So after simplification, s equal to 16.1 meter. So what you have done? They given acceleration and one condition already given. What condition given? When time t equal to 1 second, the corresponding velocity and the displacement given. Now they asked what they asked a displacement velocity when t equal to 2 seconds. So what I have done? You take the acceleration equation first. First you take acceleration equation first. What is acceleration? dv by dt. Students, so therefore I have written here dv by dt equal to this equation. Then cross multiplication. I take both integration. Already you know integration method, no? So what is a dv integration? V. What is a t cube integration? T for 4 divided by 4. What minus? What is a t squared integration? 3 t cube divided by 3. What is a 5 integration? Pi t. So any integration we must add constant, no? So add a constant. Okay, so we got V. What is a condition already given? When what is a when t equal to 1 second, the velocity equal to 6.25. So I applying here. Why I applying here? We want C1, no? So we want C1. Understand? We want C1. That's why I applying first condition. So velocity given where t equal to 1. So we got C1. So apply C1 again the equation. Again here apply. What is our aim? What is what is the velocity when t equal to 2 second? Again equal to apply it here. T equal to 2 second. Okay, so we got it 8 meter per second. Now they asking again what is the aim? Displacement. So we have only V equation. What is it? This V equation? Understand? What is the V? ds by dt. Understand? ds by dt. So cross multiplication. Again I integrate both sides. What is ds integration? Yes. So d for 4 integration. T for 5. 5 into T for that is already 5. That is 5 t for 5 divided by 5. So 5 into 4, 20 minus. What is the t cube integration? T power 4 divided by 4 plus 5 t squared. What is the t integration? T squared by 2. 2 integration, 2t. Integration, you must start no constant, I add a constant. So the first condition given, and the question is the first condition given. What condition given? When t equal to 1 seconds, the displacement 8.5, 8.8 meter. So I applied here, 8, that is t equal to 1 seconds, s equal to, so s here, see here is equation, 8.8. So after simplification, we got C equal to 4.5. So again, C to apply in this equation here. So applied, so we got finally displacement equation. What is our aim? Calculate displacement. Students, call displacement at a t equal to 2 seconds. So apply here. Okay. So we applied, we got 16.1 meter per second. Students, any question? Any doubt?